Today, student, let me start the new topic, probability and theory. That is the unit number 4. Unit number 4, that is the probability of theory. So first we discuss the binomial distribution. A random variable x is said to be a binomial distribution if it takes only non-negative values and its probability mass defined is given by the formula p x r equal to, that is NCR p की power r q की power n minus r, where r equal to 0, 1, 2, 3, 4, 5 and up to so on and up to n. And that value must be 0, r is not equal to 0, 1, 2, 3 and up to n. Where p plus q equal to 1, or we can write this q equal to 1 minus p, where p denotes the probability of success and q denotes the probability of its happening, and r is the trial of success. Here two independent constant and p and q are is the distribution are called the parameters of discrete. Since we have a n sets each of n trials, therefore the number of sets with r success, we can write this capital N into NCR p की power r q की power n minus r. Hence we have the following number of success 0, 1, 2, 3 r up to dot dot n. Number of sets, that is n q की power n into nc1 p q की power n minus 1 and up to dot dot n p की power n. So now we can write this n q की power n plus n nc1 p q की power n minus 1 plus n nc2 p square q की power n minus 2 plus dot 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 n p की power n. Now here we taking capital N is common, so we can write this q plus nc1 p q की power n minus 1 plus nc2 p square q की power n minus 2 plus ncr p की power r q की power n minus r and plus dot dot p की power n, which is the binomial expansion. We can write this n into q plus p की power n. It is called the binomial frequency distributions. Now here we remark that if p equal to q equal to 1 by 2, so binomial distribution is called a symmetric distributions. Otherwise, it is called the skew distribution. Now here first we define a moment about the origin. The first moment about the origin is defined as mu1 dash equal to summation r vary कर रहा 0 to n r dot ncr p की power r q की power n minus r, where p plus q equal to 1. Now for simplification, that is a r vary from 1 to n, we can write this r factorial n upon factorial n minus r upon factorial r p की power r into q की power n minus r. On simplifications, we can write this n factorial n minus 1 upon n minus r upon r into factorial n minus 1 p की power r q की power n minus r. r to r cancel, so we can write this summation r equal to 1 to n into n1 cr q की power pr into q की power n minus r n minus 1 cr minus 1 p की power r into q की power n minus r. Taking p is common, so we can write this np summation r equal to 1 to n minus 1 cr minus 1 p की power r minus 1 q की power, we can write this n minus 1 minus r minus 1. So that is a np is a common. Now putting the values of r1 r equal to 1 2 3 and up to so on, so we get the q की power n minus 1 plus n minus 1 c 1 q की power n minus 2 into p and c2 q की power n minus 3 p square plus dot dot p की power n minus 1. We can write this np bracket q plus pq whole power n minus 1. But q plus p equal to 1, so that is 1 ki power n minus 1, that is 1. So we can write this equal to np. So that is a mean, first mean about the origin, that is a mu mu upon p plus q. So thus p plus q equal to 1, so that is a np. Now here we define the second moment about the origin, that is a mu 2 dash equal to summation vary from 0 to n r की power 2 ncr p की power r q की power n minus 1. Now here we can write this r square, that is r minus 1 in brackets plus r ncr p की power r q की power minus r. Now after separating r equal to 0 to n r minus 1 ncr p की power r q की power n minus r plus r equal to 0 to n r ncr p की power r and q की power n minus r. Now we can write this n minus 1 summation n equal to 1 to n minus 2 cr minus 2 p की power r q की power n minus r plus np. We can write this value second term, that is the np. So after simplification n minus 1 p square summation r equal to 1 to n minus 2 cr minus 2 p की power n minus 2. We can write this, that is a q की power n minus 2 minus r minus 2 plus np. That is after simplifications. Here we get the value of after simplification np brackets np plus p minus p np bracket np plus q, that is because 1 minus p equal to q. So that is a mu 2 dash, we get a required solution npq plus n square p square. Similarly here we again we find the third moment about the origin, mu 3 dash equal to summation vary r equal to 0 to n r की power 3 ncr p की power r and q की power n minus r. Applying the above similar conditions, so here we prove that the third moment about the origin mu 3 equal to n minus 1 n minus 2 pq plus 3 n minus 1 p square plus np. Again we find the fourth moment about the origin. We can write this mu 4 dash summation r equal to 0 to n r की power n r की power 4 ncr p की power r q की power n minus r. Mu 4 dash equal to summation r की power r equal to 0 to n. Applying the above similar process. Now similarity, here we get the mu 4 dash equal to mu 4 dash equal to, that is n minus 1 n minus 2 n minus 3 p की power 4 6 n minus 1 n minus 2 pq plus 7 n minus 1 p square plus np. So that is a moment of fourth moment about the origin. Now when we define the moment of the about the mean, the first moment about the mean is always 0, so we can write this mu 1 equal to 0. Second moment about the mean, we can write this mu 2 equal to mu 2 dash minus mu 1 dash square. Now here from above we put the value of mu 1 dash, that is n square p square minus n square p square. Mu 2 dash and mu 1 dash, putting these values here, so we get the mu 2 equal to npq. That is called the variance sigma square mu 2 equal to npq. That is a standard deviation sigma equal to under root npq. First moment about the mean. Third moment about the mean. Mu 3 equal to, we can write this mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 mu 1 dash ka whole cube. Putting all above values in these relations, so here we get the required solutions. Mu 3 equal to npq q minus p. Similarly, we find the fourth moment about the mean, that is mu 4 equal to npq 1 plus 3 n minus 2 pq. Now again we define the Karl Pearson coefficient. Now here beta 1 equal to mu 3 square and upon mu 2 q upon mu 2 q इक्वल टू एन पी क्यू ब्रैकेट क्यू माइनस पी का स्क्वायर एन पी क्यू का होल क्यू and beta 2 equal to mu 4 upon mu 2 square. Putting the values of mu 4 and mu 2 in these relations, so we get the beta 2 3 plus 1 minus pq upon npq. These two values beta 1 and beta 2, again we find the gamma 1, that is a kurtosis under root beta 1. Putting these values of beta 1, so here we get the q minus p upon under root pq, and gamma 2, that is a beta 2 minus 3, so 1 minus 6 pq upon npq. So here we noted that the mean equal to NP, variance equal to NPQ, standard deviation, that is under root of NPQ, under root NPQ. So that is the moment about the mean. Now, for example, fit the binomial distribution following data. The theoretical frequency, that means expected frequency, is given that x equal to 0, 1, 2, 3, 4, 5, and frequency that is 2, 14, 20, 34, 22, 8. Now here we given that n equal to 5, summation n equal to 100, f into x equal to, after additions, 284. So now applying the formula mean equal to np, so that is np 284 upon 284 upon a, so that is a p equal to 0.563. 56 is binomial distribution is n into p plus q to the power n. So that equal to 100 into 0.43 plus 9.968 whole power n. That is a binomial distribution. It's okay, students.